Hello everyone. We are going to start with normal distribution. In normal distribution, we're going to look at some of these topics. We're going to look at what is a normal random variable, how can we graph a normal random variable, apply empirical rule, do some examples, then we look at the standard normal distribution, and we will be also using normal distribution to approximate binomial distributions. So let's start here. Now, before we go deeper into a normal distribution, let's do a little recap of things we have learned about. So here we are, just remember that when we started with probability in our earlier video sessions, probability, we talked about the quantification of uncertainty. That's how it all started. Like, suppose I flip a coin. Now, when I flip a coin, what happens? I have no idea whether I will have, and I'm flipping a fair coin, by the way. So when I flip a fair coin, I might get a head, I might get a tail. So that's uncertainty. Probability helps us to quantify that uncertainty. We looked at some probability axioms. Now, in axioms, the most important one was, what's the probability of a sample space? Now, remember, sample space is every possible outcome in an experiment. That was one. And also we learned that if we have an event, which is a subset of a sample space, the probability of an event lies between 0 and 1. And then we looked at some basic probability rules. So let's look at some of the rules we have looked at. The first one was the complement rule. Now, what was a complement rule, if you remember? The complement means the probability of the complement of an event or not event, E, is 1 minus the probability of the event. Then we also looked at the addition rule. So what was the addition rule? In the addition rule, we talked about the probability of A union B's. Now remember, A and B are events. So if you remember, the addition rule was probability of the event A plus the probability of the event B minus probability of A intersection B. And then we talked about something called disjoint events. So when we had disjoint events, what we were saying? Disjoint means that probability of A intersection B is 0. So in that scenario, what happens to the probability of A union B? So in that sense, if my events are disjoint, that means they have nothing in common. So probability of A union B became probability of A plus probability of B. We'll be seeing that happening very soon in our examples in this video too. Okay, so then moving forward, we talked about multiplication rules. So when we had multiplication rules, we were looking at probability of A intersection B. Now there were two cases we looked at. One was the independent event. So if my events are independent, that simply means that these events do not affect each other, simple words. So when you looked at the probability of A intersection B, it was probability of A times probability of B. Okay, then we had another scenario where we had dependent events. Okay, so let me just get this little. So then we had some dependent events. And in the dependent events, we focused more on the conditional probability. Very important, guys. We will be seeing it too. So conditional probability. What's conditional probability? If you remember the nice little notation of A vertical line B, it means if an event B has occurred, what is the probability that A will occur? So that's where it is. And the formula was probability of A intersection B over probability of B. Now those were the things we talked in the basic probability. And then we talked about random variables. Okay, so let's look a little bit more on the random variables. Okay, so in the random variable, so let's see here. So let's talk of random variables. So when I say the word random variables, I'm going to use the short form notation RV. Now, what's a random variable? A random variable, guys, is a quantitative variable whose value depends upon chance. Okay, so we have that. Now, there were two kinds of random variables. So let's look at the types of random variables. The types we looked at was discrete, and the other one was continuous. Now, in a discrete random variable, a very simple example is, suppose if you go to a store and then you want to look at how many items a customer is purchasing, and you would like say, suppose I'll take a little experiment, you do it for an hour. Now, what the number of items a customer is going to purchase is uncertain. So you say, okay, suppose the first customer purchased 0 items, 1 item, 2 items. So this is called a discrete random variable. And we also talked about the binomial distribution. That's an example of a discrete random variable. That's where it is coming. Okay, now a very important aspect of the random variables is that if I say x is a random variable, what it simply means is, in simple words, that means x can take some values. So x can take some values, and each of these values, there are two important parts, guys, keep in that. And each of these values has a probability. Okay, it has a probability. Let's write it down properly here. Okay, now, so this one, so if I say x is a random variable, that means that random variable will take some values. Some of these random variables will take some values, and each of this is a probability. So then we say that our, so what basically it also simply amounts to saying is, we can say that every random variable has a probability distribution. Earlier we talked about binomial and discrete random variables. We talked about a binomial distribution. So here we are going to talk about a normal distribution. Okay, so that's the recap of certain things we have done before. Now let's go back, guys, to studying about normal random variables. Okay, so what is a normal random variable? A random variable that has a normal distribution is called a normal random variable. Now these are some of the characteristics. It's a continuous random variable that can take on all possible values. It's a bell-shaped curved. So that's when we say, oh, x is a normal distribution or x is a normal random variable. Remember this nice little curves we have been looking at? So these bell-shaped curves is basically kind of giving us that, oh, we are having a normal distribution. Now this one, it is symmetrically distributed around its mean. So when we write down a normal random variable, remember the means, the mu's and the sigmas, so the empirical distributions, that's where it is. So this is where it says it is symmetrically distributed around its mean. What it simply means this is that 50% of the distribution or the values of our random variable lies to the left of the mean mu, and 50% of the values of this random variable lie to the right of this mu. That's it basically means here. And they are definitely arise in the study of natural and industrial systems such as businesses, psychology, nursing, mathematics, statistics. So in a nutshell, we say if we think of a random variable as being approximated normally distributed, so basically we're talking about this bell-shaped curves. And then later on we will see that this normal distribution also approximates many discrete distributions. Remember just a few minutes ago I was talking about binomial distribution? That's one of the things we'll be talking also here. So a normal distribution also approximates many discrete distributions. Now, let's start with when I say, oh, x has a normal random variable. So when you see this word saying x has a normal, so what basically it means is x has a normal distribution which is represented in terms of its mean and standard deviation. That's what it simply means. If I say x has a normal distribution, it says what basically I'm asking is, oh, do you remember those two parameters, guys? That means those parameters I'm talking about is the mean and the standard deviation. So that's the main important aspect of a normal random variable. And yes, this is when you go to higher statistics classes, that's where you'll be looking at this. For us and this session, and this class, we are basically going to talk about is a normal distribution being represented in terms of its mean and its standard deviation. That's more important for us. Okay, so when I say I have a normal random variable, so what is, I can represent that as this nice little bell-shaped curve. And remember I talked about the mu, that is where 50% of the values are on the left and the right of this mu mean over here. So this guy's, this nice little curve is also called the normal curve. Okay. This is important for us. So when I say x has a normal distribution, I don't want to write x has a normal distribution with mean, mu, and sigma. So we try to concise it and we say, hey, x has a normal distribution. So this notation is a very powerful notation. It says x has a normal distribution with mean mu and standard deviation sigma. That's a Greek word. These two are Greek words, guys. And this mean is always written first. So that's kind of the norm we go by. We write the mean first and then we write down the standard deviation. Okay, now let's see how when we're going to use this in solving some problems. So let's look at some of the ways the questions can be asked to us. So if I say if x has a normal distribution with mean this, so what basically in your mind is, oh, x has a normal distribution with mean, mu, and standard deviation sigma. Now remember, it is basically, so when you're looking in terms of a graph, so this is like a nice bell-shaped curve and these are values. How do we look at them is like if I say probability x is less than x. What this basically saying is that what are the values, what is the probability that the shade, this shade is this shade, guys, is kind of representing the probability that the normal random variable has values less than the small little x. Remember, a random variable is the one where it can take some possible values. So these are those all possible values of x. So we would like to know what are those values, or what is the probability that this random variable will have all the values less than x. What we do is we represent it as the area under the normal curve, and the shaded part to the left of x represents x strictly less than x. It is the same as probability x is less than equal to x. Very important. Remember, our normal distribution is a continuous, it represents a continuous random variable. Now, in this class, we'll be focusing more on using our TI-84 calculators, so normal, CDF. So if I say x is less than equal to x, or I say probability that x is strictly less than x, In either of these scenarios, we will be using normal CDF minus 999 comma x. So these are basically the endpoints of the distribution which we are trying to find out the probabilities of, and the very end we write down the mean and the sigma of that corresponding random variable. Okay, sometimes you can get questions which says probability. What is the probability x is greater than equal to x? Okay, in that scenario, so we like to see how can be shaded. So this way is basically x is greater than equal to x. So just roughly draw your nice little, the normal curve, and then this is your mu. Suppose my x is here. Okay, so my x is here. This is my x. So this point, guys, is my x. So probability x is greater than equal to x. That means this shaded part. But remember, so when you want to solve it using calculators, okay, let's focus more on the easy way of looking at it. This means this is the lower limit, and the endpoint is a very high, high value, say 9999, and then you have mu and sigma. So you can easily find out the probabilities of this normal distribution. There's another way we can get a question, and it's this: suppose our endpoints are values which are inside the normal curve. So here, kind of, right in the middle. So we say we really know the real value of where your x is greater than equal to and less than equal to b. So what simply it means is the area of the region under the normal curve between the 2 points A and B. And what do we do to find the calculator? Just simply write normal CDF. The lower endpoint of the interval, we are looking at the probabilities. The upper endpoint, then as usual, we talk about the mean of the normal random variable and the standard deviation of this normal random variable. Let's go ahead and do some examples. Now, guys, that your professor loves to have tea. So here is an example taking of her tea drinking over, say, a period of time. So here's what your professor found out, that the amount of tea your professor is drinking each day has a normal curve or distribution with the mean of 55 ounces and standard deviation of 6 ounces. My very important suggestion to you guys is the moment you see these kind of problems, you should automatically create the normal curve, write down the values. That way it will become very easy as time goes by. So when you read this one, the amount of tea your professor drinks has a normal. So the word, you see the word normal distribution, you should be thinking, what is the mean and what is the standard deviation? As you see this one, the thing you should be looking at it is, can I write down the notation? That's the first thing you should be doing. Write down the notation. So this normal is mean is what? 55 and 6. Once you've written down the notation, then my recommendation to you is go ahead, make this nice little normal curve and write down the values. It will help you guys. Okay, so remember where the mound of this bell is, that's where you write down the mean, that's your mu, which is 55. Then we go to the right, adding deviations, one at a time. So first time you add, it's the first standard deviation on the right. So 55 plus 6, 61. Then you add another 6. That means 61 plus 6, 67. Then another one, which will be 67 plus 6, 73. So fill up the numbers on the right-hand side, and also fill up the numbers on the left-hand side. So we have the numbers here. As you go back, 55 minus 6 is what? 49. 49 minus 6 is 43. And 43 minus 6 is 37. So that's the first thing you should be doing once you read down the problem given to you and you see the word normal. That's two things you should do automatically. Now let's go ahead and look at the problems given to us. It says shade the appropriate regions beneath the density function. Remember, the density function is probability x greater than or equal to x, and so that's how the questions are, and find the following. So when I want to find what is the probability x is less than or equal to 55, what would be the nice curve? We have already done the work for us. I just have to go, oh, 55 is right at the middle point. And if you remember that this bell curve is, symmetric around the mean. And we just saw earlier that if it is symmetric around the mean, that means 50% of the observations lie to the left. Okay, 50%. And remember, we've done problems on probability. 50% means 0.5. Okay, this is just by understanding the definition of the normal curves. But if you want to still apply the rules, the formula, so you can say normal CDF. Now remember, you're starting from here, so it will be negative. Now this negative is very important, and I will show you on the calculator. Minus 999. Now remember, this is the lower end or the lower limit here, and the higher end or the higher limit is 55. And after that, what are we going to do? We're going to write down the mean, which is 55, and 6, which is the standard deviation. We're going to plug it in our calculators, and you will see the answer. So let's go ahead, get the calculator here. Okay, so here's our calculator, guys. So you want to use this distribution. So what I would recommend to you is click on second and click on wars. So what you will notice is, let me just get to the side. Oh, sorry, guys. Moving this here. Okay, I want to get so that you can see what I'm looking at. Okay, so you see normal CDF over here, guys. So when you clicked on second and wars on your window, you will see distribution, and then use the cursor keys to take it to the number 2. And just press enter. So your enter, guys, is at the very bottom, and so you will see it this way. This is, let me just show it to you. Okay. So let me. Okay, I might have to squeeze the screen, guys. Okay, so that we have everything at one go. Okay, good. So let me just move this around. Hopefully I can show it to you at a nice little one place. Okay. Good. So we can see the movement here. Okay. So this is what we are looking at, the screen. Okay. So let me repeat it again. So we would do second and wars here. And then this window will open up, taking the cursor using this to the second, and then you press enter. And this by default is minus 99, so let it be as it is. What is my upper? So take with the cursor, it is, remember the upper is 55. 55. Then take the cursor down, your mu is 55, guys. And your standard deviation is 6. Then go ahead, take the cursor to paste, and then press enter. You will get this on the screen, and then again, go ahead, press enter. What do you see the answer to be? 0.5000. That's what you need. And we also got that answer just by looking at what the definition talks about to us. So we just said it. Remember, this is where it is symmetrical about the x-axis. That is one of the characteristics of a normal distribution. Also, we saw that when we plugged it in the calculator, we got the same answer. So it was 0.5. Okay, now let's talk about probability x is strictly greater than 65. Let's first shade the region. So you get the region here. And we already know if it's between 55 and 67, somewhere over here. So I'm just going to write down the terms I need here. 55, and that's why this comes in very handy. Don't notice that when I'm, guys, maybe One is 67, and then this is 61, 67, and it's somewhere right here, that's 65. That says probability x is strictly greater than 65. Okay, so let's shade the region, draw this, and then shade. Now, according to the formula, it is normal CDF. Now remember, the lower part is 65 now. The end, because, you know, x can take any values, it's a whole real line we're representing here. So we just write a bigger number, 999, and then write down the mean, which is 55, and then 6, which is, remember, our standard deviation. Then we go ahead and plug it in our calculators. Once again, I will get the calculator here for you guys. Okay, let's go ahead, do it together. Second was, then using the cursor, go to number 2, normal CDF, enter. Now the lower end, guys, remember, is 65. So 65, upper end is now 999, and then the rest as it is. Take your cursor down to paste, press enter. Again, enter, you get the answer to be 0.04779. Just 5 decimal points is good enough for us. Okay. So let's write down what was the answer we got on our calculators. 0.4779. Okay. Now let's go ahead and do more problems over here. The probability is between 49 and 55. Now, if you remember, if you keep that little, handy in front of you, this little normal curve, it will help us. So 45 is somewhere here and 55. So it's somewhere in between the two. So what you're going to do is, when you're going to draw our little normal curve beneath here, remember 55 is your mean, and then you go 6 down on the left, which gives it 49, and then you get 43, and 45 is somewhere in between. So we're looking at 45 here, and then we just do, make 2 vertical lines below the normal curve. Remember, this is the normal curve and the x-axis, and then just shade like that. Now, when you want to find the answer, okay, what do? We say normal CDF. Now, 49 is the lower value. The upper value is 55. Then this 55 and 6 last is the mean, and this is the standard deviation. Once again, we're going to plug it in our calculators. So guys, I want you to take your calculators out and do it together with me. So second inverse, taking the number down, then lower is 45, remember, upper is 55, and then 55 and 6 are the same. Take the cursor down to paste, press enter, enter. What is the answer we are getting here? I hope I've written down the right words. Oh, it's 49, guys. Sorry. It was 49. I'm sorry, I made a mistake. So let's redo again. So this is going to be normal CDF. Press enter. It's 49. Sorry, I made a mistake over there, guys. 55 and everything is the same. So I'll recorrect that over there in a minute. Enter. Answer is 0.3413. Okay, I'll make the changes as I said earlier. It's 49, not 45, guys. I wrote it correct, but here, I made a mistake. So let me redo it again. So let me just, this is, okay. It was 49, not 45. I don't know what I was thinking, because I think the 65 got to me. No. This is what we guys looking at. We are looking at 49 and not 45. Sorry. we're looking at 49 and 55, and then this one, guys, I'm sorry, I made a mistake. So normal CDF, we wrote this one there, we got the answer to be 0.3413. 4 if you want. Okay, let's look at 55 to 61. Okay, let's do this one. So if you look at this one, so here's 55, and remember when we go one standard deviation, it is 61. This is exactly the same what is happening in the previous one, which was from 49 to 55, but now it is from 55 to 61. And remember, you will notice that it is symmetric. So what is happening over here, what is the probability here, is exactly the probability here. The only thing is one is on the left and the other is on the right. So now here, the 55 is on the lower end, 61, 55, and 6. So when you put it again in the same calculator, I'm going to do that again for you guys, you will notice the answer is exactly what we got earlier. Okay, so let's do this one. Second inverse. Take the cursor to number 2. Now it's 55 to 61. Keep that in mind. 55 to 61, and then the same, the rest is the same. And then you go ahead and do enter, and then do enter. You get exactly the same as the previous one. Okay. So let's write that down. This is equal to 0.34134. Now let's look at this one. Probability x is strictly less than 45 or x is strictly greater than 65. Now we have done this part, but let's first shade the region. So when we shade the region, guys, now this is 55. Remember, we go 61 and then we went 67. 65 is here. When we go on this side, 49 and 43. So let's look at the terms we're looking at. We're looking at 45 here. And it says x is less than 45. And then we say, you're going to look at OR here, very important. So this is 65 and x is greater than 65. Now remember from our addition rule, if you remember that very nice, A union B. I just talked in the beginning of the session that if your events are disjoint, these are two events, x less than 45, strictly less than 45, and x strictly greater than 65. They're two disjoint events. So clearly the probability of A union B is what? Probability of A plus probability of B. Remember, this is my A, guys, and this is my B. So what does that mean according to the addition rule? This is x less than 45 plus probability x strictly greater than 65. Now remember, we just did this problem earlier. Let me show you this one. X greater than 65. Do you remember this one? So we can just basically pick up the value 0.4779. Oh, it was 0.4. Sorry, guys, I forgot to write this one. Again, I made a mistake. So it's 0.4, guys. Okay. And yep, my mistake, guys. So when we write this one, it is 0.04779. Now let's look at this one, x less than 45. So it's normal CDF. Oh, trying to squeeze, that's not right. Okay, so let's write this one. This is equal to normal CDF less than 45. It's negative 999, 45, 55, and 6. What are we going to get? Let's go ahead and get our calculator. Okay, now here, second inverse. Once again, number 2, press enter. Now, this is negative 99. Very important, that negative, guys, is this, not the minus sign. It is this negative, minus, right, 999. The upper one is 45. And then 55 and 6, paste. This is exactly the same as x greater than. So it's 0.04779. Okay, let's write that down. It's 0.04779. Then from x greater than 65 is 0.04779. When you add that in your calculators, you get 0.09558. Okay? Thank you, guys. In the next video, we're going to talk about empirical rules and examples and stuff.